up to this point, you've been taught section by section. Oh, look, here's a perfect square, factor it. Oh, look, here's a trinomial, that's a perfect square, factor it. Here's a difference of squares, factor it. Now, they're throwing you into the deep end of the pool, and they're saying, I don't know what pattern it's going to be. You need to figure it out. Okay? And that is exactly what this whole lesson is. Now, I'm going to go over the examples. I'm going to give you several of them just to try and help you see what it is you're looking for. And we'll go from there. So, let's start with the book's example 1. Remember, there is no necessarily, how do I say this? They're not telling you what to start with. So you have to figure it out. Okay, the first question, is there a greatest common factor? Okay, that's the way I always list it. Is there a greatest common factor? Does anybody see negative 4n squared in that mess? And the reason I'm taking negative 4 and not positive 4 is so that this item will be a positive. So yes, there is a greatest common factor, and it is negative 4n squared. After I've pulled that out, I'm left with n squared minus 10n plus 25, if I did all my arithmetic correctly, right? Then the next few items is patterns. Okay, and I'm not writing it the way they have it, but are there any patterns? Is this the difference of two squares? No, it is not, but this is a perfect square and that is a perfect square, which leads me to the possibility of it being a perfect square trinomial. Let's test that. N and 5. Square root of the first term, square root of the last term. If I double the product of A and B, can I get a negative 10? What must the sign be in order for that to be true? Negative. So that squared is the pattern. Bring down what you had above, negative 4n squared, and you now have the factor. Now, Gabe and a couple of you were listing this, but you weren't doing this when you were doing your perfect squares. N minus 5 is not going to give you n squared minus 10n plus 25. N minus 5 times n minus 5 will. Okay? So if you identify that it is a perfect square trinomial, either you must list it twice or indicate that it is a square with the exponent. Okay? That's one example. Here's another one, and this is in my book. You won't have this, so copy it, please. Okay. Is there a greatest common factor?
Yes.
What?
Oh, just well, it's wrong.
Nope, there is a greatest common factor. Try again. A is correct. A. Pull A out. And you end up with a pen dropping on the floor. Is there anything else you could do? No. They might throw something simple like this at you. This isn't a difference of squares, even though that's a perfect square and that's a perfect square. The A is not. Now, had I changed it to this and that, then I could pull, shoot, that won't work either. A squared come out of that, A, yeah, that won't work. Anyways, you get the idea of what I'm trying to do. I was going to make up another problem, but we won't do that. We'll just keep going. I don't want to make up a problem. All right. How about example 2? Example 2. 5a cubed b squared plus 3a 4b minus 2a squared b cubed. Okay. Is there a greatest common factor? Maybe, but I'm going to tell you one thing. We list them in decreasing degree of the first letter. That's A. List them in decreasing degree of A. That is going to make it easier for you to see. So the one with the largest degree of A is going to go first. 3A, 4B. You with me? 3A, 4B. The next item is the one with the A cubed. Positive 5A cubed, B squared. The last one is the A squared. Negative 2A squared B cubed. Now you might be saying, why didn't you list it in decreasing degree of B? Because you generally just think alphabetically. Okay, Ben, are you with me over there? You guys okay over here? All right. Now, clearly I can see my greatest common factor because everything is in order. Looks like A squared B? Is that right? A squared B. And once I pull that out, I have 3A squared plus 5AB minus 2B squared. Okay, so far so good. Anything else? The 3, the 5, and the 2 share nothing. We already pulled out the variable greatest common factor. There is nothing else. So yes, that's your final answer. All right. Don't be afraid that you might find that. Example 3. A squared BC minus 4 BC plus A squared B. So it's already listed where I've got decreasing. I mean, there's 2 of them with A squared. BC 4BC plus A squared B minus 4B. I mean, there's nothing else I can do, like to regroup, like to make it decreasing degree of A, because I have an A squared here, no A, an A squared here, and a no A. So, is there a greatest common factor? No, except for B. B, 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 B. Let's pull B out. And this is going to be trial and error, people, guarantee it. Pull out your greatest common factor of B, which is going to be A squared C minus 4BC plus A squared minus 4.
You forgot to take a B out of 4B.
Yep, thank you. Okay. Now that I've pulled everything out, what kind of patterns do we see? Anything within that mess that you see that might be interesting? Well, I'm going to tell you right now that if I take this, now we're going to ignore this for a little while. That's going to rejoin us at the end. But this shares C. You guys see that? So C times A squared minus 4. And that's a difference of squares, isn't it? This one is also a difference of squares. A plus 2, A minus 2, and of course this one was A plus 2, A minus 2. Okay, but you've got this C sitting here, you've got that B floating out there, but C plus what? What can we join the C with? Well, there's a plus sign here, a 1. Because in order to hold this, you have to have a 1. So this is C plus 1. Okay? And both of these are repeated, A plus 1, A minus 2. So if you just write them once, because this and this both share the factor of that, the C shares this with the 1, which has that. Okay? This is tough. C plus 1 a plus 2, a minus 2, b. Yeah. Okay. You found something that everything shared. You found the opportunity to pull out the c, and this was a perfect square. So to hold the position, you plugged in a 1. C plus 1 multiplied by the difference of squares multiplied by the b. Now, how can you verify that you are right? Anybody have any idea how to verify? Multiply! Very good. Okay, so I clearly shouldn't see anything where you don't check it. At least tomorrow. Today is odds, but tomorrow, I mean, there's no reason not to check yourself. Okay, no reason other than laziness. All right, we're going to do some oral exercises. Okay, we're going to do a couple of these. Starting with number 7. This is oral. Number 7. 10a squared minus 15ab squared. Greatest common factor, is there one? 5a is right. She's right. 5a, 2a minus 3b squared. Okay, what else? What else? Is there any patterns here? Difference of two squares? No. Perfect square? No. Any other common factors? Any grouping? Then that's your final answer. That's it. How about 9? T cubed minus 9t. What are we going to pull out, or what are we going to do?
Pull out t.
T is correct.
And then you get a perfect square.
T squared minus 9, t plus 3, t minus 3. Good job. That was your GCF, and this became difference of squares. All right. 11, this is the last one I'm going to do with you guys. P cubed minus 2p squared q plus pq squared. Should we pull out p? All right, let's pull p out. P squared minus 2pq plus q squared. Difference of two squares? No. What else do you see? What's the next pattern we can double check? Perfect square. Yep. Is this a perfect square? Is this a perfect square? Is that a perfect square? So the square roots of those are p and q. Can I multiply these two together, double it, and create a negative 2pq?
Yes.
How? Negative. Is that my answer? No. What's missing?
Little square at the end of
The little exponent. Okay? You have to have the exponent. Because p times p minus q is not this. That's p squared minus pq, but it is not this until you square it. Okay?